3.3. Metrics SLI, SLO, SLA. Engineering measurements with intent. Reliability is one of those words that everyone uses, but nobody defines in the same way. One person says, "The system is reliable." Another says, "We had only one outage this quarter." A third person insists, "Our uptime is excellent." All three statements sound positive. But none of them actually answers the most important question. Reliable? According to whom? And compared to what? That's why modern engineering teams stopped relying on impressions and started relying on something firmer. Measurable language. Everything begins with the simplest building block: metrics. Metrics are nothing more than numbers measured over time. They track what a system does, not what people think about it. A metric can tell you how long requests take, how many succeed, how many fail, how many users are active, or how often a component restarts. Metrics are neutral. They don't blame, they don't explain, they don't comfort. They just describe reality as it unfolds. But the truth is, systems have many metrics, sometimes hundreds, sometimes thousands, and staring at all of them at once does not bring clarity. It brings paralysis. So teams ask a more focused question. Which number best describes what our users actually experience? Not what the servers feel, not what the engineers feel, what the users feel. That number becomes the SLI, the service level indicator. To keep it simple, SLI is the measurement of user experience, expressed as a number. It is not philosophical. It is not abstract. It is just a clear metric that answers, from the user's point of view, how often does this system behave the way it should? Depending on the system, the SLI might be the percentage of requests that succeed, the average response time, or the percentage of time the service is actually available. Nothing fancy, straightforward reality. For example, in the last hour, 99.6% of requests completed successfully. That number is our SLI. It captures the experience of thousands, maybe millions, of users in a single value. It doesn't guess. It doesn't exaggerate. It simply tells us what people actually saw when they used the system. And once we can measure experience, a new question appears. What level of this number is acceptable? That decision becomes the SLO, the service level objective. It sounds like this. We aim for 99.9% of requests to succeed. The SLO is not an inspirational slogan. It is a line we deliberately draw. It says, above this line, we consider the system healthy. Below this line, users are being affected and we must respond. In other words, the SLO admits something engineers sometimes hate admitting. Failure will exist, but we will define how much failure we are willing to tolerate. And then there is the final step, when reliability stops being an internal engineering conversation and becomes a public commitment. When that same promise is written down, shared with customers, and sometimes connected to refunds or credits, it becomes the SLA, the service level agreement. It sounds more like business language. We guarantee 99.5% monthly availability. If we fail to meet that, we compensate you. At that point, reliability becomes more than numbers on a graph. It becomes part of trust. Customers aren't just hoping the system works. They are relying on a promise the company is willing to stand behind. In real life, SLOs are usually tighter than SLAs. You aim high internally, so that the external commitment remains comfortably inside your safety margin. And this is where the whole model makes sense as a sequence. Metrics collect facts. The SLI chooses which facts represent user experience. The SLO defines the reliability we strive to maintain. The SLA turns part of that promise into something customers can rely on and hold us responsible for. When a team adopts this language, conversations change. Instead of endless debates about whether a system felt slow, engineers can say, our SLI dipped below our SLO yesterday between 1800 and 1900. Let's investigate what changed. Instead of panicking when something breaks, teams can ask calm, structured questions. Was this outage still inside our tolerated budget? Did we hit our error threshold? Did users notice? And if they did, why? Over time, metrics, SLIS, SLOS, and SLAS reshape not only systems but also culture. They educate everyone, developers, managers, customers, that reliability is not magic. It is a balance, a negotiation between speed, cost, complexity, and user experience. We stop pretending that systems can be perfect. Instead, we build systems that are honest about their limits and designed to remain trustworthy within them. That honesty is what truly defines professional reliability engineering. Not the number of dashboards, not the loudness of promises, but the ability to say, with precision, this is what we measure. This is the level we aim to keep, and this is the promise we are ready to stand behind. That is the real meaning behind metrics: SLIS, SLOS, and SLAS, turning reliability from intuition into a discipline, and from vague reassurance into something users can actually depend on. In interviews, companies rarely ask about these terms just to test vocabulary. What they really want to see is whether a candidate understands the mindset behind them. Strong candidates don't say, "We try to keep systems reliable." They say things like, "We defined our SLI, set an SLO around it, and used incidents to learn when the gap widened. Our goal wasn't perfection. It was staying inside the promise we made." That answer tells interviewers something important. This person thinks in terms of measurable promises, not just hope and intuition. Now that we know how to talk about reliability, not as a feeling, but as a measurable promise, the next natural question is, how do we build systems that can actually keep those promises as they grow? That takes us to the next topic: scaling strategies. When to scale up, when to scale out, and how those choices affect stability, cost, and resilience. End of 3.3.